Hello there guys, and welcome back to another epic Inexorable video. This is the first video we're going to be talking about circles, which is really actually quite exciting. It's an interesting topic in my opinion. This is the equation of a circle. The introductory video to circles, we're also talking about the equation of a circle. This here is the equation of a circle. It looks a little bit daunting. X minus a squared plus y minus b squared equals r squared, and r is the radius of the circle. But like, first things first, before we do any problems, any questions, I've actually just thought, like, loads of people ask, why, where does this come from? And by the way, a and b are the center, the coordinates of the center. Didn't mention that. But people ask, why, where does this come from? Where does this formula come from? Well, you're noticing something already, aren't you? Something squared plus something else squared equals a third thing squared. Now you're also potentially looking at a bit of Pythagoras, and I'm just going to show you where it all comes from. This is obviously supposed to be a circle. It's not a perfect circle because I drew it, but imagine this was a perfect circle. So, and imagine the circle had a radius, arbitrary radius of r, lowercase r. That means you could draw a point anywhere around the circumference of the circle, and it would always be r units away from the origin, wouldn't it? Because a circle has got a constant radius. That's the definition of a circle. It's got a constant radius, which means if you draw a line like how I've drawn one from the origin to any point around the outside, it would always be r units long. Also, just like in any graph ever, you can define a point on that graph to be some arbitrary xy point, xy. It's got an x coordinate of x and a y coordinate of y. And you might think that's not very helpful, is it? Because it's just like, yeah, obviously. But what it means is we can do something. If this arbitrary point, which I could have drawn over here, down here, up here, over here, up here, over here, anywhere, I could draw it anywhere around the circumference of the circle. I just chose to have this line going this way, but again, it could have been anywhere on the circle. If this is some arbitrary point, which could be anywhere on the circle, then and it's got an x coordinate, then it means the distance, the horizontal distance from the origin to the point on the x-axis that is directly below that point, that distance is some arbitrary distance, x. Likewise, with y, you can also see that if we have a y coordinate, then of course, this is the corresponding horizontal distance here to our y, and of course the vertical distance from the origin to the y, this length here, is also y units, y. Which means, guys, and I've drawn it over here with a nice arrow, you can actually see it. There's a triangle here. I've even drawn a right angle. There is a triangle that I've replicated so you can see it, and it's clearly got an arbitrary length here of x, an arbitrary height of y, but it's always got a hypotenuse of r. Now that triangle could be of any shape as long as it's a right angle triangle. So again, if I was to use a ruler, I could have a triangle that looks like this. That is really awful, but just imagine it's a triangle. Imagine it is. And this is some arbitrary x length, some arbitrary y length. As long as this r is the same as this r, which it doesn't really look like it is, but as long as it sort of hypothetically is, that is, you know, that's a triangle. As long as these r's are the same, these x and y coordinates can actually, they have a relationship. And that relationship is the square of the x value and the square of the y value have to equal the square of the r value. Why is that? Well, it's because this is Pythagoras' theorem. Once again, there it is. This is Pythagoras' theorem. This is a right angle triangle. A squared plus b squared equals c squared, where c is the hypotenuse. X squared plus y squared equals r squared, where r is the hypotenuse. We're just changing the letters. They're the same thing. So we can use this. And again, we've got, as long as the x coordinate squared plus the y coordinate squared is always equal to the r coordinate, or the r length there, the radius squared, then it is a point on the circumference of the circle. Now, that's assuming that the origin is the center of the circle, because obviously, if AB was 0, 0, then this would be x minus 0 squared plus y minus 0 squared equals r squared. Now, the minus a and the minus b dictate where this circle is. It's a translation. This is like in the form like f of x minus a, or f of x minus b, or f of x plus a, or whatever you want. It's in that form. There's a video on it translating graphs. So essentially that's where the minuses come from. It's basically a translation. It just moves the circle. It doesn't change its shape. It just moves it around. That is where the formula comes from. Okay guys, so we're going to try out a question now. We're going to be looking at finding the equation of the circle with center 3, 2 and radius 4. So what's the equation? What's the equation of that circle? Using this expression or equation, we essentially get the following. If the center is 3 minus 2, remember this A is the center. So this A is kind of like this 3 and this B is kind of like this 2. So we can say that like A is 3, B is 2. We essentially take X and Y. Remember, they're always in the equation because they don't change. They need to be there. We have got X minus A, which is 3 squared, plus Y minus 2 squared, because that's kind of like our B again. And that's equal to, the radius is 4, but we need to square the radius. And 4 squared is 16. So this is the equation of the circle. I will now put it up on Desmos so you can see what this looks like. It's going to have a center of 3, 2, radius of 4. This is the equation. There you go. You can see it right now on Desmos. It's beautiful. Okay, let's try out another one. Okay guys, so this is going to be a little bit harder, but I think we can still do it. We want to find the equation of the circle now with a center of 5 minus 6 and a radius of 2 root 3. Okay. Right, how do we do it? We just go straight in. So x minus the center, the x coordinate center, which is 5 squared, plus y minus, careful, minus 6. So I'm going to go straight in and we're just going to go y plus 6 squared, because this is y minus 6, which is y plus 6. And again, we square both of these guys. And then we set that equal to 2 root 3 squared. So that's going to be 2 root 3 squared. Now, how do we square something like that? Well, guys, there's a few ways to do it. You can use a calculator and it will do it for you. Remember, when you use a calculator, you must put it in brackets. Otherwise, what it will do is it will do 2 times 3 squared, or sorry, 2 times root 3 squared. It won't do 2 root 3 squared. So you need to make sure it's all in brackets because of BIDMAS, because of order of operations. It will square it. It will square the root 3 and then times it by 2. So you get root 3 squared, which will be 3, and then it will times it by 2, which will give you 6. That's wrong. So essentially what you need to do is, there's 2 ways of doing it. You can either square the 2 and then square the root 3. Just distribute. So you can write it as 2 squared root 3 squared, like that. That's fine. And then you can get 4 times root 3 squared. Root 3 squared is 3. 4 times 3 gives you 12, which is the right answer. Or you can do it this way if you want to. You can say, I'll do it over here. You can say that 2 root 3 is the same thing as the square root of 4 times the square root of 3, right? Because 2 is the square root of 4. So these are the same. The root 3 doesn't change. We've just rewritten 2 as root 4 because they are the same. Root 4 is 2. And then, guys, because we have 2 surds timesing, we can write it as 1 surd, which is equal to root 12, like that. And then we essentially have root 12. And then, guys, all you need to do is say, okay, well, 2 root 3 squared is, because 2 root 3 is the same thing as root 12, it's the same thing as root 12 squared. And guys, root 12 squared is 12. The root and the squared cancel. So it's 12. So you can do it either way, whichever way you fancy, but yeah, well, there's 3 ways really. There's those 2 ways and then there's the calculator. That is the answer. Beautiful. Again, it's going to go up on Desmos and you can see what it really looks like. So you can see that and you can just look at it intuitively. Think about the center. The center should be at 5 minus 6. And then the radius, if you look at the radius, you do indeed get that the radius is 2 root 3. But it's we use 12 in the equation. Okay then guys, thank you so much for watching, I highly appreciate it. We will continue these questions, we'll do like not a part 2, but like a continuation of this sort of topic. We'll talk about some harder problems, I don't want this video to get too long, but thank you guys so much for watching, I highly appreciate it, and I'll see you in the next one. Cheers.